he unmute? I can mute him. So I'm in charge. Mute Robin.
Test, 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 test. I'm assuming that's working. Hopefully that's working. Let's go to the video. All right. So, welcome everybody to the nth TWed of the. I guess we're the spring 2016 term, aren't we?
Yes.
Yes.
Just a couple of logistics before we get started. We are streaming this live out to the interweb. It will be recorded and it will be available via YouTube, via the TWed page after the broadcast. Just keep that in mind if we have questions, that sort of thing. We're happy to have our longtime TWC PhD student Robin Liu, presenting today on laboratory information management and ontologies and all that other cool stuff. It's meant to, I know Robin worked really hard on this presentation. He's got all sorts of notes that I'm not allowing him to see. Robin, it's meant to be informal, so we appreciate you putting in really hard work in this presentation. I saw it right, just ahead of the thing. So it's a lot of good work put into it. But please feel free to ask questions, and let me worry about the time management. And we'll have a good discussion as we get to the end.
Yeah.
All right. So take it away, Robin.
Okay, thanks. So hi everyone, I'm Robin. I'm now currently the third-year PhD student working with Professor McInnes, and today I will mainly talk about the LIMS work, which is the Lab Information Management Systems I've been studying recently, and mainly the topic is mainly about how we're gonna use both LIMS and ontology for the laboratory data integration task, specifically for the chair use case we are currently ongoing, and also how it overlaps with our class projects on another chair use case.
And you shouldn't expect that people know what cheer is.
Chair is the child health exposure. And what does the A mean?
Environment and
environment. Yeah. Yes.
Analysis
Repository project that's focusing on, I think, the child's health and the development issue. And on RPI side, we are mainly responsible for the metadata support and data maintenance and management. Technical support for the organization and the big project. So let me give a very brief introduction of the data integration itself. So the data integration actually involves combining data that are residing in different sources, like in different data sets, different data resources, and the goal is to provide the users with a unified view of this data. Like for example, in this very simple example of a data warehouse, so through the ETL process, so ETL is like extract, transform, and load. We will be able to like convert all these different data sources into like a unified, for example, one data warehouse. So actually, this process is significant in a variety of situations, because currently in both, for example, commercial applications, which usually like two companies, they are doing similar things in the same industry. They need to merge their database if they want to do collaboration. And like scientifically in academia research, the collaborators need to combine their research results from, for example, different bioinformatics repositories, like a geo repository, things like that. So if things are in the same domain, there certainly such kind of integration task needs to be done in order to achieve like mutual benefits and big collaboration. So yes, there's many open problems remains unsolved. So yeah, this is a more complicated one. So consider if we have a web application where a user can query a variety of information about, for example, like cities. Like in a city, we need to know the crime statistics and how about the weather and how about the demographics. So traditionally, the information are stored in a single database with just a single schema. But usually, like for example, an enterprise will find information of this somewhat difficult and expensive to collect. So even if the results exist there to be able to gather, but most common case is we will duplicate data in existing like 3 different databases. Like for example, one for the crime database, one for the weather websites, and one for the census data. So this schematic for is a typical solution when we have 3 different data sources. Usually the developer or the designer just use a mediated schema to create a virtual database via 3 different wrappers without like editing or modifying the original schema of each data source. So in this way, we can do data integration without unifying them into actually one single database, but we can still achieve it through a virtual database. So this is part of how LIMS works. So currently, the laboratory information management system I'm working on is called LabKey. It's an open source LIMS system. So this is actually now the only open source platform I know, which is designed for scientific data integration and also allows the users to do any customizations, and especially if we want to integrate bio or medical related data, for example, the clinical data, specimen records, and other experimental results. And it actually enable users to do a lot of meaningful things, like we can map, define the relationship between different entities within a study, or like for example, the participants' cohorts visits specimens, and it provides like enable SQL, and also if we have do an extra wrapper on that, we can use the Sparkle API, and also it can link, provide access to external data sources, like for all the SQL methods here. So yeah, so it's like quite flexible regarding dynamic database access, and yeah, and especially since it's designed for like clinical and medical data repository, so it's very like clinical user friendly if you want to create and customize your own data fields. For example, you want to have like your import your data as some list as a data study or specimen. It has built-in like definition and modules available for you. So currently, one of the largest installation of this LabKey server I found is called Atlas. So it's managed by the Statistical Center for HIV and AIDS research and prevention. So at a cancer research center. So yeah.
I have a question regarding the last 2 slides you mentioned.
Which one? This one?
Both.
Okay.
So for this slide,
This one?
I didn't see if it supports some semantic, like Sparkle-based queries.
It's not Sparkle-based query, but Sparkle is an additional option you can pursue, because it provides, in the next slide here, it provides such API that you can have access to RDF data Sparkle, because you can either link it to like traditional relational database, like PostgreSQL, SQL, like Microsoft SQL, but you can also link it to endpoint, SPARQL endpoint, such as like FSQL, virtual service point. Because it also provides like the R API, like you can use R script, like Python script, also use Java to do extension. So this is LabKey server's modular architecture. So it consists actually of all the core services here. In green, these are all the specified specialized modules. And the modules, actually these modules are autonomous, and the blue ones are all the shared service. So for these green modules, you can actually like add or delete, remove, or even upgrade independently to add new functionalities if you want, without touching the like core services or shared services it has.
So I'm not sure. Do you want to re-ask your question?
Yeah.
Because I'm not sure you got an answer to that. And this is as far as help.
The answer is no. Okay. It's a relational system with an API.
Yeah.
Conventional API. So that didn't finish my question. When I see your go to the last two slides.
Mm-hmm.
Forward. So when you're saying that you have a wrapper and you have a schema.
Well, this isn't.
This is
not
module. This is not LabKey. This is data integration solution.
Yeah. So this slide and the previous slide, excuse me, Robin is just giving some background.
Yeah.
Traditional ways of doing integration, and then he's discussing LabKey, and from this text, as Ray's pointing out, it looks like it's you've got different SQL options, and but the question is, so you go to the next slide.
Well, but before you go to the next slide, he does say fields can be annotated with things from curated ontologies. So you could annotate with things like UMLS, but it doesn't appear, although you can correct us if we're wrong, that there's any particular support for connecting to ontologies.
Because if you're storing RDF data in triple stars, that's considered as external resources.
Yeah,
yeah.
Talk to that on the next slide at the bottom. So that you're saying that on the bottom there, you can have different kinds of
So you could have a triple store
It's
there.
a kind of external data resources.
But you need the various modules that can make sense of that, right?
That's like you add a new functionality, like whatever, like you write some like a Python module or wrappers that talks to a endpoint.
But is there a module that lets you come in through that LabKey API and get at data that's stored in a triple store at the bottom? Does that actually
That's something you need to do, but it's not.
Oh, so it doesn't exist.
Yeah, it's not already
Okay.
there. It's for you to customize.
And what about that ontology word? So experiment : name ontology. What's that?
So this is the data field in the previous one, like when you are defining or predefining your data types, the data you are importing, you can like create like a customize, because if you are the administrator, you can create your own data field. Like you can map them to the ontologies you are using. So these are actually now like you are defining them according to your like predefined concepts in the like whatever ontology you are currently using.
the reverse of Tim's converter. It's turning Tim's converter into a
It's just providing a
Yeah.
way to like manage your thing easier. Like you have you won't like misunderstand, or you will mix some concepts, but they are not actually the same. But you have duplicate or unnecessary vocabularies here. Yeah. So this is like a traditional, like an example procedure, the typical steps. For example, this is a flow of design and asset data, which I showed to Paulo last week. So it's briefly speaking is an administrator goes to LabKey and you create an folder in the type of, for example, assay folder. So now the folder is acting as a basic staging for you to start. Then, for example, if I'm a scientist, I can then create a new assay design in this folder and to design it to match all the contents of the experimental results I have in my spreadsheets or the spreadsheets I received. This is in section A. And then the scientists can actually add a set of batch fields. That's the customized data fields that must be filled out when a single run is needed. After you filled out these fields, then you not until you filled out all these fields, then you can run one batch of the things you have imported here. So after you fill all the required batch fields, then you the scientist will define the run fields. That's in section B here, the general assay results, and
I think it's the scientist postdoc.
Oh, I'm sure it is. And so this one, they expect that the person who's doing this is assay literate.
yeah. So in this example, it's actually only one field. I think it's the machine setting. Only the machine setting fields is defined. So in this run, every time you run one batch, you need to fill in the machine setting field.
Huh.
Yeah.
You can't pull that?
So
Well, so the idea is you're a scientist, you've got a lab, and you're doing some sort of thing.
this
So you
is
go in
like
and
the
define this
scientist.
data model.
Like he infers the assays data, actually assays data fields from a spreadsheet file.
Okay. So
Since
can you
these
import
fields-
from spreadsheets?
Yeah, this is
Okay.
input from spreadsheet, and you add specific batch fields. For example, here you must enter machine setting before you can run one batch. Yeah, this is a must be filled in property.
And who
Defined.
comes up with the column names? Is that
This is in the
pre-populated?
spreadsheet.
Okay.
This is the column names in the spreadsheet.
It's provided by LabKey.
Yes.
Or
No,
that's provided by
this
the
is when you
scientist.
input the spreadsheet.
Okay.
It's already generated, but
Okay.
you just add the batch.
So what does it mean, the
properties.
batch? So
Just you are telling LabKey you are importing an assay data.
oh, so you've got like a folder full of spreadsheets.
Yeah, you create a folder. You tell LabKey this folder is of type assay, and then you import
One of
and
them.
spreadsheet into this folder. Then it knows you are importing an assay data. The spreadsheet contains assay data. Then you set the batch field for the imported assay data, and one required then must to be filled in blank is the machine setting. That's what you define here when you import the
So I don't know that much about assays, but I think that means that the scientist is going to have to map their spreadsheet
So
to
these
LabKey's
fields could
spreadsheet.
be just customized by the scientist when they design it manually, or it can be automatically done by the LabKey. But sometimes there must be something you want to add manually because it won't guess everything perfectly. It will just basically import all the columns, and if it says see something the column name is SAID, then he knows it's something should be English letters or combined with
Yeah, but what if it's like
figures. Integers.
ASID, not assay ID? Does it?
But it still knows it's an ID, so maybe it will set it as a primary key if it's the only ID column.
So is it
In the
trying to do some mapping between the scientist column headers and what it knows about assays? So if it knows that assay ID
Uh-huh.
is typically on assays, and I come in with ASID. Who
Then
figures
you
out that they're
will,
the
you
same
will,
thing?
the scientist will
Scientist
pick
does that
one
matter.
as
Yeah.
a primary key, yes. Yeah, so it's the same manner as the vector and the fields. So this is just a flow of how a scientist input on a spreadsheet and record it and run it in LabKey. So when we talked about ontology-based data integration, we always thinking about how ontology can be used to help with integration rather than the traditional normal ways that we do, for example, just using one kind of LIMS. So, so currently, according to my learning and understanding so far, I think ontology-based data integration is the use of ontology to more effectively combine the data and all information from especially multiple heterogeneous data resources. So, for example, the role of the ontology, the three most significant role of the ontology is for content explication, which, because when we use an ontology, it is actually more accurate way to interpret data from multiple sources, because we need actually explicit definition of the terms and very clear and accurate relations between these terms, concepts, or entities. And also in some LIMS, not only LabP, but also some commercial ones or scientific repository, they enable the query model for you can just use the ontology itself, like one single ontology as a query schema for querying all the data in your LIMS. And also the verification, that is because by having an ontology, we can verify all the mappings used to integrate data when we are integrating data from different or multiple resources. So usually we use, for example, one single ontology, or we can sometimes use multiple ontology, but in this case, we need to resolve the issue of how to map different multiple ontologies when we are integrating using multiple ontologies. Because sometimes we always having one specific ontology for one repository. Like we have 4 or 5 different data sets, and we have 3 to 4 different ontologies. So we always need to first map the ontologies before we can do the integration. So for example, for the biomedical thing, the OBO ontology is mostly used because I think it's OBO or OBO.
Well, so it's OBO here,
OBO
right? It's not
Foundry.
OBO, yeah.
Yeah. Because
yeah.
this ontology is designed specifically for data integration for all the biomedical concepts and the terms. And it is designed to support the biomedical data integration. So this is our plan of how we're gonna integrate LIMS and Hadatac. So Hadatac is the thing that Paulo have been talking about this during the past 2 hours. This is a 1.5 year of development.
He's been talking about it for 1.5 years.
Yeah. So the idea is currently in Hadatac, it has metadata including for example, the instruments, the measurements, all the metadata from the sensor, all the
Human aware data.
home-aware data.
Collection framework.
I don't see this.
And contextual
Oh, the framework is at
text
the end.
aware.
The
Collection.
Hadatac
Yeah.
framework, but what? So
The human
collection.
aware data
Collection.
data collection.
Data collection.
Yeah, data collection.
but it does
Oh, I
not.
see. It's,
Human-aware data.
it's like one of those puzzles.
Yeah.
Well, yeah. So it's actually capital H, capital A, capital D, lowercase a t a, capital C.
The key is.
Yes.
It's at the middle of everything.
Yeah.
So currently it has, like, for example, this part of the metadata that's collected by Hadatac. But some of them, like 1/3 of the metadata which are missing, is like things like the data calibration records, like the instruments registration and the instruments like calibration record or track of all the calibration procedure. So this is where we think LIMS can help to like regenerate and merge integrate this data. So the first thing is we export whatever metadata we have from Hadatac. Like, for example, for the Jefferson data Paulo showed us, they collect some metadata from that's currently already stored in Hadatac. We export them and a CSV and feed them into the LabKey, which is the LIMS we are using. And then we use LIMS calibration module and the features that, for example, if I'm a scientist, I can like add all the calibration procedure or data fields I need. I think it's important for this data. So by having the data and the metadata from Hadatac, and also the calibration data and the metadata we recreated or generated when using LIMS, then we can output a complete metadata rather than to feel like to, in addition to the original metadata that Hadatac already has. And the exchanging, the import and export part, like the state, like the schema and the concepts we used while this like exchange and update is actually part of the shared ontology we are having during this metadata integration.
Why? So you're saying that in LIMS there's additional metadata.
It links because in Hadatac currently they do not have a user interface that a scientist or a domain expert can perform any action on the data. For example, you have a spreadsheet. In LIMS, you can import it and do all the marks.
Okay. So
Yeah,
I see. So there are fields
yeah.
that calibration for all the stuff you were saying that Hadatac has a place for, has no interface for.
So
And
yeah,
then
LIMS
in order
is
to
served
create an
as
interface,
an
you import
yeah,
it
yeah.
into the LIMS system. It generates those
It's served
those
as
fields,
an
and now
interface.
in the context that they know how to use LIMS, they can update that information.
Yeah. So when we were chatting about this last week, I don't know. One of the things that was striking all of us is LIMS has been used for a while by a lot of people. And it's got at least what looks to us as a pretty decent interface. It might be more than decent, but it's at least decent, and a lot of people are beating on it. Interfaces take a long time to build. Even crappy ones take a long time to
But
build.
it's more importantly, it's the interface they have, right?
Right.
It's the one they have.
Yeah, because if we are
Well,
going to
This is an open source. I mean, it is used by a reasonable number of people, but a lot of the big players use these commercial systems, but they cost a fortune. So we got the one for free that probably covers 95% of what all those commercial LIMS do. I mean, the commercial LIMS probably have nicer interfaces, more support, but they at least have the same.
Well, they need more support. I mean,
Okay.
that's what makes them commercial. Right?
Yeah.
It's the support.
because if we want to develop an interface for Hadatac, that will be maybe another year's work. But now we're just trying to use LIMS as like LabKey as the interface for the.
Well, I think
Hadatac.
it's a great thing because I mean, the point is you don't have to have an interface to Hadatac to use the advantages of Hadatac.
Right, right.
That's so. If you're able to take those advantages that Hadatac is providing and get it to, I mean, it's similar to what Laura
Yeah.
did. You know, it's a similar kind of thing where she's using Hadatac or the predecessor of Hadatac to improve what they're doing with those instruments, with the platform, and with the instruments.
Right. And the other thing is, I think, but you know, who knows? I don't bet on this kind of thing. But I think that these open source systems are going to take off more and more. So if you look at the history of artificial intelligence software, they used to cost $100,000 for just the software, and then you pay probably $500,000 for the consulting. And you know, nobody could afford to do that. And now there's a bunch of open source or way cheaper things. This thing is decent and maybe better than decent, and a lot of people are starting to jump on that bandwagon. So if we're compatible with this emerging open source LIMS system, you know, I think we're going to kind of be leading the way. Plus, we lower the barriers to entry. So now you don't have to have $1 million budget or a $500,000 budget. Now you can use an open source system and be compatible with our stuff.
So is it actually open source in the sense of
LIMS, yeah.
It is.
I mean, LabKey, sorry.
Lab-
Yes.
LabKey.
so people are writing extra modules to it?
Yeah, you know, I think, you know, I don't know whether it's going to be as successful as some of these, you know, Linux or something, but you know, I think it's got a shot because these systems are too expensive for them to be sustainable, I think.
Well, but usually the LIMS systems and similar are part of a larger ecosystem within within laboratory management in general. So at Yale they actually adopted Encore as a kind of a larger package
Yeah.
around biorepository management, kind of clinical annotation and like patient record management, LIMS, and a whole bunch of other stuff.
Right, they're part of these giant packages, but that
Right.
means that you got to be the Yale, you know, Yale is really well funded. You got to be the Yales of the world to really kind of get, to be able to buy the $1 million solution, because that is a $1 million solution. And like Michigan has done a roll your own. They've got a pretty sophisticated one that I saw some glimpses into in November. And I think they were the only ones, we've got 6 partners on Cheer. I think they were the only people who did a roll your own, but they get to do these customized dumps. You know, basically they do their own extension requests. These other people have to ask the commercial entity to go do the extension request for big consulting bucks.
It's interesting. Michigan's got a long history of sort of the educational software platform busting. You know, I think they were behind some of the initial efforts to bust Blackboard and put their support and build consortia to do open source development of alternative solutions. So
Well, I don't think there's, I'd have to check on this, but I'm pretty sure their stuff is not open source. They just did a roll your own. So their whole infrastructure is built by them, or at least their LIMS infrastructure is built by them. And so it's very customizable. Sorry, I'm taking over.
Yeah, it's just expensive to buy commercial LIMS, usually, especially for the labs and the university. So, okay, when it comes to the Cheer, our class use case, so now we are, I think, finalized on the use case.
Yes, you're fine.
Yes. So briefly, is now currently we are having starting from 2 different studies, but it's actually on the same general topic. So these are 2 different questionnaires provided to I think the patient or maybe the doctor. I'm not sure, but it's all on the same general topic. That's asthma-related topic to child's health. So the first one is asking all the asthma-related questions. The second one is asking the smoking-related questions, like whether anyone in your family or father and mother is smoking or things like that. So the ultimate goal we have here is to come up with ontologies that can eventually compare, map, and then integrate these two studies and completely understand what are the common fields, what are the overlaps, and what are different, and how one affect the other. So by having such an ontology, this is actually similar to part of the ontology I mentioned before for the Hadatac and the LIMS integration. So we hope all these final product will be part of and can be used for the big chair project and eventually become part of the final chair ontology we are providing to the data center. So for the chair project, the big picture is our goal is to help because they have 6 different labs, and Monsana is building and setting up a new data center for merging and managing all the data from 6 different labs. So we need to come up with a solution or approach to help them integrate, manage, combine, and also understand each lab's data.
Modeling questionnaire as an instrument.
I think we are
Not like a VSTO instrument. What do you mean instrument?
Well, an instrument in the sense of the data collecting thing.
Yeah, they're called instruments actually.
Yeah, well, and they're legally they're called instruments.
Studies.
Well,
But
no,
there's
studies use an
Yeah.
instrument.
Studies use an instrument, but the instrument is that's what you call.
So this is actually
That's
what
an
you guys got.
Like the-
Oh, okay, cool.
Yeah, like the sort of multiphasic is actually an assessment instrument.
Okay, that's interesting because I don't know whether it's going to. Our current modeling of instrument is really going to be general enough for this to be a subclass.
Well, it's something to think about though.
Yeah,
Because that's
yeah.
I mean that both from a so in the medical and the survey thing, you
Yeah.
think of instruments, but also I mean instrument is also used as a legal term, slightly different.
Yeah,
But it's meant to be this. It's a thing. And it's, so you can kind of think in this way of the data that's produced by this instrument. And
Yes.
what are they used? What are the scenarios in which this instrument is used?
Yeah. Actually, we should look. Actually, why don't you take this as an action?
Yes.
I'll send you an email. To really look carefully at whether this would fit well underneath the Hadatac instrument.
because we were trying to just model
It'd
and
be cool if it
encode these 2 questions. Because
Yeah, I mean, we should have a generalized view of instruments and that it does fit. I just don't know whether it does today.
Well, and it might be a nice way to solve other problems because so just as an example, these 2 questionnaires. Do you know the scope of how many questions are?
like a dozen.
So
Yeah.
some of the questionnaires that we've
Some
seen
are long.
for other work, these are of the order of even thousands of questions.
Oh.
in the questionnaire.
The ones that I've seen from them are more
But
like
is it
50
for
to
a
200.
patient to fill
No.
thousands of
They're for scientists or field workers to fill.
manually
Yeah.
for
They-
one study?
Yeah.
But
Yeah.
is that even
But
real?
that's well, I mean, it's so understand that you might be so certain kinds of questionnaires or studies. What do they call it when you jump ahead? When you're in a study and you answer a question in a certain way. And you
Oh, and then you go, I don't know.
Skip logic.
skip logic, right? Some questionnaires are built with skip logic, so there might be 13,000 questions. I mean, those are legitimate things that have to go in the ontology, but you're not going to ask 13,000
Like
questions.
if section 4 is yes, then
Right.
it's right section 5. Otherwise, go
Yeah.
to section 6.
That's right. But they can be almost like programs in the sense
yeah.
of how their complexity.
This is just like a decision tree. Something similar.
Yeah. But just on the
Yes. Yeah, so our goal is to use the ontology to help combine and contrast at least these 2 studies and eventually figure out like when they may be able to like be combined.
Do you have ways of, is there, I mean, it's not here yet, but sort of identifying the nature of the missing data? So sometimes.
You mean the missing data in Hadatac?
No, so as you think about this modeling, there's one of the problems you have is sometimes there's missing data because if it's a person, if it's a patient or a subject that's answering questions, sometimes they will skip.
Yeah.
Skip certain questions. So there's a and sometimes when you look at, sometimes you can deduce what the reason is for the missingness of the data. Sometimes it matters in how you deal with the missing, in your analysis, how you deal with that missingness. So if there's a way that you could, it's just something to think about.
Yes, that's something we need to consider when we draft the ontology. Take this into account. Yeah, sometimes if the ontology is well written, some can be auto-filled. Like if key blank is filled, then some others can be skipped because we already know the answer about the ontology. Yeah, so that's why when we're doing this, we need expert support for drafting when we are drafting model these concepts.
Yeah, I mean, you're going to have to do your own draft, and then you're going to probably have to point them to look at particular things. I mean, it'd be great if they look at the whole thing, but you're probably going to have to point them.
Yeah, so currently we have a selection of variables from the study. I think Susan called it grouping up healthy.
Oh.
Yeah, so that is part
stuff.
of the breast cancer and the research program. So they select this as a subset of the variables that can be used to address some hypotheses they mentioned. Also, we mentioned in the previous slide, like something like whether smoking in the home increase the risk of asthma regarding to this specific study participant, and whether the data included in all the documents could be used to address things like whether increased body size is associated with increased risk of asthma, or whether smoking in the home would be like an important factor for maybe another hypothesis, that is, for example, body size would be an important factor for the first hypothesis, the relation or the impact among each other, like whether smoking is has something associated related to body size. Body size is has impact on the smoking at home.
Okay, sorry, the first hypothesis was what again?
The first hypothesis is whether smoking in home would be an important factor for asthma, for increased asthma. And the second one is whether an increased body size would be associated with increased asthma.
Right, and I think they already know that the answer to that second one is yes. I can't imagine the first one is not yes.
Yeah, so this is an example, whether we can use this to address all this, use this data to address all these hypotheses, or whether that's not enough, we need to collect and find more data included in whatever documents we can find that we have.
Right, and I don't know whether you've got it, but Susan told me on the phone that phthalates are associated with increased body size, and they know that increased body size is associated with increased asthma risk. So the work they did on phthalates is not for naught, because it impacts.
Yeah, I think phthalate is yeah, still associated with asthma issue. So it certainly has association and impact, but not in these two study and
Oh.
question here.
Oh, you don't-
Did you see any?
No, so I was
Yeah.
just going to say that the new information, new data that sends us, there's no mention of phthalates,
Yes.
either in the questionnaire nor in the data or the data history. I was a little confused as to, I know that you just mentioned the indirect relationship between phthalates and asthma, but it didn't send us any new. I think we got some new information just now, like 10 minutes ago from
Oh,
Susan,
okay.
but I didn't see it.
Well, you can just focus on those two studies for now, but she told me in the last 24 hours that phthalates are correlated with increased body size, and increased body size are associated with asthma.
So if any of the new information she sent us, we have anything, any relevant information on phthalates, then we.
Well, that is something she hoped we can discover via these documents by ourselves.
Oh, well, you're not getting the data, right? You're
Yeah.
just getting the metadata. I mean, without the data, you're not going to discover this.
Yeah, like I'm not sure whether she wants us to infer from ontology that we know like phthalate is related to
No. That's her job.
asthma.
That's the
Okay,
that's
yeah,
the
yeah.
epidemiologist
Then we
and
need
the
to have
statistician's job.
we need to have additional data. I think.
Do we need any, like, so we go with the phthalate approach as we had decided for the phthalate and obesity, and then add asthma information to it, and then kind of try to find association between phthalate and asthma? Is that how we're going for the approach?
I was going to be satisfied with you doing a good job of modeling these two data collection instruments, which I will now appropriately phrase them that way, and showing what the connections are between them, because I expect that you're going to have hierarchical relationships between them, and you're going to have some things that there's gaps in one that are covered in another. So, and one of the reasons that this came up is because they're really interested in when multiple studies make sense to combine together. And one of the ways that you can figure that out is what information did they collect?
Mhm.
So if you're interested in asthma, did you collect whether either a direct statement that somebody's been diagnosed with asthma or information that's correlated with asthma that predisposes you to have asthma? And if not, then these studies are not going to be very useful to put together with relation to trying to figure out what's going on with asthma.
Yeah. Okay. Yeah. So eventually, we hope like a better use of ontology and the LabKey and also Hadatac can help us achieve the goal of the chair project. Like we can have a good ontology to help with either the data and the metadata integration in the end. So there's still a lot of work to do. So I hope we can both do a good job in the chair project and also in the class project, and we have good results.
Yeah,
at the end
and
of the
so back to your question, have you or anybody started to encode the phthalate study information?
No, we haven't started importing anything. We were going to restart for the new thing from the use case. So we just
Yeah,
split our
okay.
work. 2 people work on the use case and 2 people work on the term list. And for the term list purpose, if you're going to start from scratch for this approach, it doesn't seem to need any phthalate information, at least based on what they sent us.
Okay, well, so give me an update tomorrow after you look at whatever was sent. Because I would like you to do an ontology for those two data collection questionnaires. And what might make some sense is to also look at Nancy's questionnaire. But you don't have to integrate that into your homework for submission.
I just saw what Susan said, which is quite small questionnaires.
Oh,
So I like to
Yeah.
Okay. yeah, so look at them, tell me what questions arise, and then we'll make a decision tomorrow.
So when we create like new term list, we should still consider the original questionnaire besides these two.
If all of these, if you have enough overlapping information on the questionnaires with relation to asthma, just stick with that. I have no idea what she said.
Oh, you mean the original one? If
Just-
there's
just
something
these two.
related, okay. Yeah, because I don't think the previous question here from Nancy has anything to do with it. But we will look at that again.
Well, but they do have demographics, right? I mean, like where did you
Yeah,
live?
that's all the common because like the gender demographic things are separate questionnaires because there's a folder of
Oh, that's a separate one.
questionnaire. This is just one of the
Oh,
aspects.
okay. So, but you do have something on demographics, right?
Yeah.
Yeah.
Like
So they
gender
care deeply about
demographic, yeah.
demographics, and you know every questionnaire is going to have.
Yeah.
demographics.
This I think these are all the must ask thing. So they all purchase
Yeah, so if you do-
separately as
If you do a good job on demographics and do a good job on body mass relationship, body mass stuff,
Mhm.
and asthma stuff, that will be great. If you can do more, that's even better. But that by itself will be great.
Okay.
We'll use it, so that'll be good for the class, and that'll be good for cheer.
We'll shape the use case that way. We have to start up the use case again, right? So the use case and the approach and shape it so that it focuses on what you just mentioned.
Okay, sorry, I keep
That's-
derailing you. Where are you when you talk?
I'm at the last slide.
Yeah, he just started
Yeah,
he
but-
was doing his,
so
so I hope it all works
Yeah.
out great.
Okay.
yeah, I just hope we have good deliverable by the end of the term.
All right.
Yes, that's all.
So thank you very much, Robin. Were there any other questions? This has been a good discussion.
So it's John.
Well, he was not in the
Okay.
hangout,
Oh, I
but he
thought I
might
saw
have been.
him join at some point.
No, he was not in the hangout, but he may have been in the YouTube.